So we've been talking non-metals. In our last class, we looked at sulfuric acid. Okay, I will prepare sulfuric acid using the contact process. All right, so contact process is what we looked at in our last class. So let's look at a compound of sulfur oxide. So sulfur oxide, the lab preparation of sulfur oxide is the reaction between the acid, hydrochloric acid, and sodium sulfates. Okay, this is specifically sodium. All right, let's get that +1, that's +2, +4. So this is a sodium trioxosulfate 4. Yes, sodium trioxosulfate 4. All right, so this is the setup. The reaction between hydrochloric acid and sulfur trioxosulfate 4. Okay, solution. So to give us salt, water, and sulfur oxide. So these are our target products, sulfur oxide. You can see it is dried over concentrated sulfuric acid. So this is another use of sulfuric acid as a drying agent. Remember, okay. So it dries that, and then that's to remove the water, and then we have it's collected by downward delivery. So basically, it's heavier than air. So downward delivery right there. So properties of sulfur oxide include it's colorless with irritating smell. It's an acidic gas which turns litmus damp litmus. All right. So still on the properties of sulfur oxide, it's an acidic gas which turns damp litmus red and then bleaches it. So that's the reaction. Sulfur oxide reacts with damp litmus paper and it forms an acidic solution and it bleaches. So it has bleaching properties. That means it decolorizes the damp litmus paper. It's very soluble in water to form trioxosulfate 4 acid. That's what it looks like. Okay, so that's trioxosulfate 4 acid. All right. So chemical properties include that it reacts with alkalis to form salt and water. Of course, it's an acidic oxide, and that's one of the reactions. All right. So it also has reducing property of sulfur oxide. Is a test for sulfur oxide. Reducing property of sulfur. The reducing property of sulfur oxide is one of the tests for sulfur oxide. What do we mean? If it reacts with the chromates, okay, no dichromate as the case may be, it turns it from orange to green. So it reduces the chromates, okay, and that reduction accompanied by a change of colors from orange to green. So that's a test for sulfur oxide to know that sulfur oxide is a gas, okay, or not. So it also reacts. It also reduces this. All right. So that's a test for sulfur oxides. Okay, reduces chromium 6, the chromate 6. All right, chromate 6. Yep, chromate 6 to chromium 3. Also permanganate from here to here. So there's a reduction with a change in color. So the purple permanganate becomes colorless, while the orange chromate heptaoxochromate becomes green. All right, it also has bleaching properties we said earlier by removing oxygen from the material. So it becomes all right. So what happens here is that the sulfur oxide dissolves in water to form this acidic substance, okay, which adds oxygen, or rather removes oxygen from the material. Okay, so it bleaches by removing oxygen from the material. Now, to bleach is to make a substance colorless, but it's not as lasting as chlorine. Chlorine bleaches by adding oxygen. All right, but this bleaches by removing oxygen, and the material becomes reoxidized by atmospheric oxygen. So this is not permanent bleaching like chlorines. All right, so let's look at the. We said sulfur oxide has oxidizing property when it meets a stronger reducing agent. All right, so in this case, remember, and so it oxidizes this, and itself is reduced. So sulfur oxide is reduced to the sulfur solid here in this reaction, and the sulfur oxide is reduced to the sulfur solid in this reaction. Okay, remember it's the oxidizing agent in this case, so it itself is reduced. So this is a stronger reducing agent. This is a stronger reducing agent. Use of sulfur oxide is include as fumigation, because it's a poisonous gas, for bleaching straws, paper, and for bleaching silk also, preservation of food, and manufacture of sulfuric acid. Okay, so the last compound of sulfur we're going to look at is hydrogen sulfide. It's colorless, it has a rotten egg smell, okay, and it's denser than air. All right, so it reacts here. How it's produced from acid again, hydrochloric acid plus iron pyrites. Okay, notice an ore, ore of sulfur to give you iron chloride and hydrogen sulfide. So it reacts with copper sulfate to give you the black copper sulfide and the acid. It also reacts with zinc sulfate to give you white zinc sulfide and the acid. All right, it reacts similarly as, okay. So hydrogen sulfide has reducing properties. Similarly with sulfur oxide, has that reducing property with the dichromate and the permanganate salts. Okay, substances. Remember we said it reduces this from orange to green. Okay, so reduces the dichromate and also reduces the permanganate. Okay, from purple to colorless. So it's other reducing property, hydrogen sulfide also. Now the test for hydrogen sulfide is that it turns lead ethanoate paper black. Alright, so that's the reaction, it turns it black. Alright, so let's look at carbon. Let's look at carbon. So carbon is freely found as graphite and diamond, and in impure amorphous forms as charcoal, coke, lamp black, and okay, they just said that charcoal. So these are the forms in which carbon is formed as graphite, okay, and diamond, and charcoal in its amorphous form. So the other forms are crystalline. All right, so now this is what diamond looks like. Okay, so it has this tetrahedral units. So there are covalent bonds between the carbon atoms, and there are no free electrons. Hence, diamond is an insulator. So these strong bonds make diamond the hardest substance known. So this is a tetrahedral unit of diamond forming octahedral crystal structure. So this is how diamond looks like. So these are the covalent bonds. There are no free electrons. This is quite different from the structure of graphite, where there's a free electron, okay, which can be used as a conductor. All right. Okay. So we're comparing the uh, octahedral crystal structure of diamond to the hexagonal layered lattice structure of graphite. So this is what graphite looks like, okay, at the microscopic level, and this is what diamond looks like. So on a different, one of the main differences that the graphite structure has a free electron, okay, has the covalent bonds where only 3 out of the 4 electrons are used in bonding. So hence, there's one free electron making graphite a conductor. This free electron is free to conduct electricity, making graphite a conductor, unlike. All right, now between each of the layers, because we said graphite has a layered structure. So between each of the layers, each of the hexagonal layers, we have weak van der Waals forces. So there are weak van der Waals forces making graphite soft and slippery. Okay, so the layers can slide over one another. So graphite is soft and it's a conductor, unlike um, diamond, which is hard, one of the hardest substances known, and it's not a conductor because it has no free electrons that can be used for conduction. All right, so diamond is used for cutting glass and for drill bits because of its hardness. Okay, so graphite is mixed with clay. Okay, uses of graphite that mixed with clay to make lead pencils. Okay, so your pencils are made of graphite, which is a form of carbon, and as a lubricant, graphite is used as a lubricant because of its slippery property. All right. Now let's look at destructive distillation of coal and wood. Remember, we're talking compounds carbon. So coal is a mixture of mainly carbon, hydrogen, and oxygen with little nitrogen, sulfur, and phosphorus. Okay. Alright, so let's look at destructive distillation of coal, and then we'll look at that for wood. So destructive distillation of coal is basically heating coal in the absence of air. So this breaks down into coke, ammoniacal liquor, coal tar, and coal gas. So destructive distillation of coal is is heating coal in the absence of air. Okay, in a closed container. It breaks down into simpler substances as coke, ammoniacal liquor, coal tar, and coal gas. The same thing can be done for wood. Wood, destructive distillation of wood. Alright, so let's look at wood. Destructive distillation of wood gives us wood charcoal, pyroligneous acid, wood tar, and wood gas. Okay, we said destructive distillation is heating in the absence of air. Alright, so we're going to stop there. Next class, we'll look at carbon 4 oxide.